All right, physiology student. Welcome back again to our second social distant learning lecture note. So you should have gone to your Canvas calendar. All right, Canvas calendar, and then neural integration. Again, this week we do not have our Kahoot quiz yet. I said yet because I want to give you guys more time to process this information before we do a Kahoot on neural integration. So open the notes. Open it with Cami. All right. And follow me and highlight the note. Speaking of note, the end of the month is coming. So don't forget we do have e-intact and notebook check. And this is our fourth note. So make sure you look up the note. The first thing I want you guys to get a chance. Let me do this. First thing I get you guys get a chance to check out this video. Okay, the video is gonna help you review on signal transduction in a neuron, how we create an action potential. Wrong video. But anyway, this is technically what you guys did with the stop motion video. So watch the video. It's 11:43 minute 43, but it really help you review to understand, to wrap up everything, because we are going to have a nervous system edulastic test. So please check out the video when you get a chance. And again, guys, the note today is not the easiest note. It's a lot of information. So I'm going to try to focus on the thing that I need you guys to know and kind of like skim through the thing that not very important. Maybe you're going to learn later on. So the first thing is neurointegration, right? So we remember this nervous system, right? The nervous system not just one thing, is branch out. It's like an umbrella. It branch out into the central nervous system and peripheral nervous system, right? Central nervous system are made of two things, right? Remember the brain and the spinal cord. The brain is where you receive information, you process. Spinal cord is the same thing, okay? But it's less complicated as the brain. And remember the brain, we talked about the brain is not just the cerebrum, but there's also like the midbrain, the diencephalon, and all those stuff, right? Cerebellums. So review those notes. And then you have neurons that are not in the central nervous system. Neurons are in your skin, muscle, throughout your body. And they are what we call peripheral nervous system. And they're divided into motor neuron and sensory neuron, right? You have motor neuron that control movement. It sends signal from the central nervous system, brain, spinal cord. It sends to the muscle and the glands. Right? We'll talk about glands later on when we talk about endocrine system. Sensory neuron, on the other hand, pick up the information, send it to the central nervous system, to the brain and the spinal cord. It's sense, right? Like hearing. Okay? Within your motor neuron, you are then divided into two things. You have somatic nervous system and autonomic nervous system. Remember, somatic would be your motor neuron that control contraction, muscle contraction. You have voluntary control. You think about it happen. It doesn't just automatically. And then you have autonomic nervous system where you don't have to think about it. It work, right? For example, heartbeats, digestion. Those are involuntary. You don't have control. It contract. And it receives signal from your peripheral nervous system. Okay, within the autonomic nervous system, you have two systems. One is sympathetic, fight or flight. You gotta remember when I threw the book down in front of Harry, he body kick in. He either fight or flight, right? And like when you see a bear, something scary, you don't have to think about it for you to get all these reactions. It just take place automatically. That's why it's autonomic. Involuntary. You don't have to think about it. And then you also have the parasympathetic, which is rest or digest, the lazy one, right? You have different type of muscle in your body that do that, and we'll talk about that. Today we're going to focus on more sensory information, sense. You are divided to afferent and efferent, right? You have afferent would be your sensory neuron, sensory pathway, things that you sense extended to your central nervous system. And efferent would be motor track, like from your central nervous system, control your muscle or your organs. Motor. So opposite way, right? Opposite way. Okay. We're gonna start out with this first. We're gonna talk about how your sensory information, what pathway, and then is conscious and subconscious, so that we think about it or we don't think about it, right? And then we're gonna move on to chapter 16 as well, higher order function, thing that require thinking, and we'll talk about that at the end of the note. So hang with me. It's a lot of information. We'll focus on what we need to focus, and we skim through what we feel is not important, or you will learn later on. Speaking of senses, right, we have 5 senses, right? We have olfactory, smell, vision, sight, gustation, taste, right? And equilibrium or balance, and then hearing. So usually we said touch, right? Feeling, right? And that is equilibrium, balance. Why? Because our body, our muscle, our feeling, touch, motion allow us to balance ourselves. So that's why you don't see touch here, but they are technically used to help us sense what's going on, okay? To keep us balanced. And then moving on, your sensory information, all right? Remember reflex, right? You have a stimulus, something that stimulate you, that would then send to a sensory neuron, and then from a sensory neuron, it then send to a interneuron, remember? And then when your interneuron are either in your spinal cord or in your brain, and from that, it's then sent to a motor where you react, right? So speaking of sensory information, right, you have sensory information, right? You either have a physical force, right? Or you have a dissolved chemical, sound, or light, right? Those are the things that help us sense, right? Sensation, some of the sensation that we might have would be taste, right? Hearing, equilibrium, which means balance, and vision. And then it communicate with a sensory neuron, pick them up, and then send it to interneuron, which is either our brain or spinal cord, and then it processes the information and then send to a motor reflex arc. So review your reflex, okay? All right, what are the receptor, sensory receptor? Our receptor means something to receive, right? So neuron that receive, right? So this will be our skin, right? And then this will be our connective tissue. And within a muscle, you have nerve, right? You have different type. You have 4 type of receptor. So make sure you know this. First type is what we call a nociceptor, or pain, right? We receive that sent through pain, and then it trigger our somatic reflex. Like let's say you hurt your hand, you hit your hand, something, pain, you pull it back, right? You can feel it, and your central nervous system will tell you to pull it back. We also have receptor that receive information for heat, heat, temperature, right? And it tend to be located in your skin, skeletal muscle, liver, and hypothalamus. You have your mechanoreceptor, or physical distortion, mechanic, tactile, touch. Like you touch, somebody touch something, you sense. Barrel mean pressure, right? You sometimes it doesn't have to touch, but you can feel the pressure. Like if you go diving in the ocean, right? You can feel the pressure pushing into it. And then you have like blood pressure, digestive, reproductive, urinary, right? Like you need to pee, you feel the pressure. And you have proprioceptor, which is monitor position in joint and muscle, right? And that's a receptor in a joint and muscle. So then we know, we can sense how a body distortion, and those are mechanical, physical. And then you have chemoreceptor, has to do with chemical. For example, you have sensory that sense pH, acidic or basic, sense carbon dioxide, oxygen level, and so on. So those are the 4 types of senses. Yes, you do need to know, so please read this note and review it, okay? And then we're gonna talk about pathway, how sensory information travel, right? Sensory, so we call somatic, right? It carries from your skin, your muscle, to your brain and spinal cord. There are three type of pathway that you need to know. One is spinothalamic pathway. Spinal has to do the spine. Thalamic would be the thalamus, right? Review your note. And this has to do with sensation in touch, pressure, pain, and temperature. It travels through what we call spinothalamic pathway. So it goes to the spine and then the thalamus. And then you also have a posterior column pathway. It's kind of similar to spinothalamic because it involves both, but it's a different position. We'll talk about that. And then spinal cerebellar pathway. So the spine and the cerebellum. Remember, cerebellum has to do with balancing, right? All right, so make sure you review that. Okay, I'm gonna try to keep this video short. So this is your spinothalamic pathway, right? And again, different part of our cerebrum have different senses, right? Here you would have more senses to the hand. This is spinothalamic pathway. So let's say you have a sense, something, you sense something. That is sent through, remember, what do we call this? This is dorsal ganglia, right? Dorsal, the back. Remember? Dorsal root. Dorsal means back. Dorsal root. Remember, dorsal root is when you have a sensory nerve that travel. So you pick up the thing and it travel to the back, right? And it go to the spine, dorsal. And it has to be, remember, dorsal and ventral? Dorsal is only for sensory. So it go to the spinal cord. And ventral here, remember ventral? It has to do with motor, right? This is motor. So it go opposite way. So make sure you know that, okay? Dorsal, ventral. So you sense, this is your spinothalamic pathway, right? It has to do with touch, pressure, pain, temperature. It will send the signal through your spine, and from your spine, will send it to your thalamus. And then it's cerebrum, different part of your cerebrum that detect that sense. All right. And then you have a posterior column pathway. It's the same. It also go through the the spine, and then the thalamus as well. But it's posterior. It's in the back. This is more in the front, right? See, more in the front. This is more toward the back side, the back. So that's why it's posterior, but it's the same. It's kind of like the same organ, back, okay? Extend in thalamus and again. And this posterior column pathway is more, again, for fine touch. So make sure you hear the word fine, like little thing, right? Fine touch, pressure, vibration. So it's kind of the same, but it's just fine. It's not combines fine stuff. And then you have the last thing would be pathway would be spinocerebellar pathway, which is the spine, and then they send information to the cerebellum. Remember, it has to do with cerebellum has to do with balance, right? Balancing, equilibrium, and it has to do allow you to create receive proprioceptive or receptor has to do with your joint and muscle, which allow us to be balancing ourselves. That's why our cerebellum. Remember we said if you do boxing or fighting, don't recommend, but if you hit somebody here long enough, they lose balance. And that is your spinal cerebellum pathway, how your sensory information travel to the central nervous system. Okay. Moving on, we have a lot sensory information. Most somatic sensory information relate to the thalamus. This is the thalamus, right? Remember, this is what we call the cerebrum. All right, the brain is not just the brain; it has different part. Remember, midbrain, medulla, the pons, medulla oblongata, right? So remember, review these things, guys. Review. So sensory information, majority thalamus. This is like a processing area, and then extend to different part of your cerebrum that for you to process. All right, and then the next thing is besides somatic, we have what we call visceral. And it's not starting from, it's not in your muscle or skin. It's more in your organs, right? Organs, see? Organs. And your organ need to be sensed too, right? Because you, for example, heartbeats, digestion, we need to sense that. And this will be then sent to the spinal cord again and to your cerebrum, right? So it's a little bit more simple. It monitor your organ, what we call visceral sensory pathway. Okay. And it's very simple, not as much as somatic. Again, somatic are more skin and muscle. All right, let's review again our somatic motor pathway because we talk about sensory, right? Sense. And now somatic. Somatic has to be with, has to do with your motor, right? So we just finished sensory, check, done. Now we focus on motor and we're gonna talk about somatic first. And remember, somatic is something you have control of. You have conscious of. If I tell you to flex your arm, you have to think about it for it to flex, right? Somatic. And then you also have autonomic motor, right? I mean, you don't think about it. So your autonomic would be your visceral, your organ, right? Organ, because you don't have to think about it, but it's still working, right? Our heart's still working, digestion still working. You don't have to think about it, and that's somatic pathway, right? So done with sensory, done with motor. Good. Speak a little bit more motor. How does our motor pathway, how the motor neuron connected? Is usually by two motor neuron. You have one coming from the brain and another one will come out from the spinal cord to connect to your muscle because remember, this is motor, somatic, right? Somatic, something I have control of, not autonomic, right? And then a lot of time you also have the interneuron. Remember, interneuron is like in between, but then it's so small, so short that we don't notice. But usually at least two neurons. So you have a neuron coming from the brain to the spinal cord, and then from a spinal cord there's another neuron that goes. So usually like at least two neurons that create a movement. Moving on, a little bit about your cerebellum. Remember what is cerebellum again? It's right here. Cerebellum has to do with motion, right? Equilibrium, balancing. Right. Moving on. Now we're gonna focus on autonomic nervous system a little bit. And again, autonomic nervous system has to do with your, without conscious, like your organs, right? It's movement, it move, heart move, but we don't have to think about it. Cardiovascular, respiratory, breathing, digestive, right? Sometimes, yeah, we can control breathing, how fast, but you don't have to think about it for you to breathe. And also reproductive, right? For example, hitting puberty, you don't have to think about it for it to work. It automatically works, right? And that's your autonomic nervous system, ANS. All right, we are done with the simple neurointegration. Now we're going to focus on the higher order function, things that require thinking, okay? Like memory, learning, and intelligence, okay? Because they both connected, right? If you create an emotion, somatic reflex, you will have to think about it, and suddenly you remember it, and next time you do the same way or not to do the same way. So, first thing is we are going to talk about the autonomic nervous system, right? Think that you don't have conscious control, right? Oh, my bad. Let's skip that slide. Let's go this slide, okay? So here they show you the connection, the pathway of how nerve connect in a somatic and autonomic, right? Remember, somatic is something you control. Flexing is somatic. and it comes from your brain. It requires only 2 neurons, right? One that go from the brain to the spinal cord, because you think about it. You don't think in your spine, think in your cerebrum. And then another one is what we call the post-synaptic neuron that control your muscle, your skeletal muscle. Only 2 neurons. But autonomic, on the other hand, has 3. That's the difference. You have come from the brain, connect to the spine. The spine then will make another connection to the 3rd neuron. And this neuron we connect to either your fat cell, right? Adipocyte, fat cell, remember? Those are connective tissue. Your heart muscle, cardiac muscle, glands, smooth muscle, which is your organs. So you have three connection. So that's the difference between somatic and autonomic connection. So yes, make sure you remember this, okay? All right, so we talk about autonomic nervous system, which you don't have control of. It happens. And remember, it divides into 2. Go back to here. Right? From autonomic, you have sympathetic and parasympathetic. Remember, sympathetic is what we call AKA fight or flight. Remember when Harry in class, he was sleeping and I threw a book down and he woke up, right? And his body autonomically kick into what we call sympathetic nervous system. And in sympathetic nervous system, you have this side, sympathetic. Your eye will dilate, open wider, because you just want to see what's going on, more light go in. Salivary gland, you inhibit salivation, your mouth get dry, because you want to shut down things that you don't need, but turn on things that you need. Your heart accelerate fast. And again, and this is right now is autonomic, so I don't think about it. So you have nothing come, well, it does come from the brain a little bit, but most of the time the spine, the cord, a reflex. Your stomach will inhibit digestion. You don't want to digest, right? And then many things, right? You don't want to relax bladder. You don't want to relax your bladder. Actually, your bladder needs to be closed because you don't want to be in peeing and running away, right? Sometimes in the movie, they show people get scared and they pee themselves, and that's because they're so scared. Okay, and then you have parasympathetic system, which is rest or digest, right? And rest or digest is the opposite. Your heart slow down because you don't want energy to go your heart. You want to focus on digestion, which is intestine. Your bladder contract, right? Oh, my bad. I take it back. Your bladder relax on sympathetic. So that's why people tend to pee, because you lose control of it. Your energy are going somewhere else to help you, like heartbeats, right? Breathing. Okay, so parasympathetic, these things, so check it out. Your stomach stimulate digestion because parasympathetic. Your eye constrict pupil, you don't need to see things, so you save the energy. Your salivary gland saliva increase because you want to digest food. So that's what we call parasympathetic. Again, these things it automatically happen. Right? Again, I talk more about some of what happened to the sympathetic, right? Sympathetic is what we call fight or flight. It release norepinephrine. It's kind of like adrenaline type of thing. It releases nitric oxide, which make you like we know our nitric oxides make people happy, so make you feel good. And this is why sometimes you hear story of people being shot. They don't feel the pain. They actually like it because their sympathetic system kick in, right? Vasodilation, increase blood flow. You want blood flow, so more oxygen, more energy. Activated in reflexes, right? You are more aware and ready. On the other hand, you have parasympathetic would be like the opposite, okay? Okay, and then parasympathetic on the other hand is the opposite. So check out those notes, but I'm gonna skip them because it's a little too long. All right, now we're moving on to higher order function, thinking. Okay, we want to talk about different things, and it has to do, high order function has to do in your cerebral cortex, right? Your cerebral, white matter, gray matter. Remember, difference between white matter and gray matter has to do with the myelin sheet. White matter is when you have myelin sheet, right? Faster conduction. Gray matter when you don't. In your cerebral. Your spinal cord, remember, is the opposite, right? In your cerebral, your white matter is inside. Your gray matter is outside. In your spinal cord is actually, your white matter is outside and your gray matter inside. High order function require your cerebrum, thinking. All right, speaking of high order, first thing we want to focus on is memory. There are 4 types of memory: fact, specific information, right? There's skill memory, where you do things and you remember. And then there's short-term memory. First is what we call primary memory. It is memory that you remember, you do it, you remember, you can recall immediately, right? For example, if I ask you, what do you eat this morning, right? You will probably remember, short-term memory. But if I wait for next month, I ask you what you eat today, you don't remember, right? You can't recall that. And then you jump into long-term memory, memory consolidation. I mean, you have to convert from short-term into long-term. There are 2 types of long-term, secondary and tertiary. So how's the difference between them? Secondary require effort to recall. You have to think about it and then you remember. For example, if I ask you, what is your phone number, right? Most of us will have to think and then we'll remember. Tertiary memory, you remember for life. If I say, what's your name? Right? You don't have to think about it. You know your name, okay? All right, so that's memory. And this is higher order and it requires the cerebral cortex. All right, memory formation and storage. So increase neurotransmitter release, right? Remember how neurons talk to each other through neurotransmitter, these chemical, they connect each other. So when you make a connection, let's say you have sensory input, right? Looking here, you have short-term memory. If you repeat, let's say I tell you, let's say I tell you my name, right? You repeat, and you remember, short-term memory. But maybe if you stop repeating, maybe 30 years later, you see me, you probably don't remember my name, right? Short-term memory. And it can be permanent loss if you don't practice or you have brain damage. And if you keep repeating, you involve it constantly, that's short-term memory or primary memory. Primary will become what we call secondary memory. That means you can recall, right? If I tell you to study, you study, right? And let's say a month later, we don't use it. A month later, it might become secondary memory. You can recall it. And if you do it long enough, it becomes tertiary memory, which is your permanent memory, where you remember for life, right? For example, if you learn this lesson, practice, you will get to a point, become second memory. You recall on the test. And then if you do it again, it becomes tertiary memory. And just imagine our jobs, right? You have a job, they teach you something, short-term memory. The next day you come back and do it again, secondary memory. And if you do it for your whole life, I'm sure it become your tertiary memory. Okay, and that's memory. The second thing we will talk about high order function is your state of consciousness or sleep. There are two types of sleep: deep sleep and REM sleep, or rapid eye movement. Deep sleep is when your whole body is relaxed. I mean, you don't have conscious control anymore. Your heart rate, blood pressure declines to 30%, deep sleep. And then when you sleep long enough, you jump to a REM sleep, what we call active sleep. This is when you have intense inhibition of somatic motor neuron. You want to make sure you're not sleeping and doing what you are dreaming of. You want to lose control of it. Some people have what we call sleepwalk, where they are going through REM sleep, but their body cannot inhibit their somatic control, your muscle control. So then they act on what they're dreaming. So what we call sleepwalking. But most of us, we able to inhibit that. It's called REM sleep. Every night, we start out with deep sleep, and then our REM sleep will hit around 5 minutes and go back to deep sleep, and then increase 10 minutes and go back to deep sleep. So it's a cycle, and that's how we get sleep. Okay, sleep has very important, right? It helps our brain and spinal cord to grow, to process information, to store information, become memory. It also allow our organ and other system to recuperate. It allow the protein synthesis neuron increase during sleep. Extend period without sleep lead to disturbance and mental function. Unfortunately, 25% of US population do not sleep enough. So they have sleeping disorder. So go sleep. Average time for a good time for sleep is 8 hours of sleep. Myself, 6 hours is good, right? So sleep. So that is our conclusion to our nervous system. Review all these notes. We start out from what make up the nervous system, what part, and then the umbrella of a nervous system, like central and peripheral. How do our nerves send signal? And today we talk about neural integration, right? So review your note and study, because the test on Edulastic is coming. So one more time, thank you. Review this note if it's moving too fast for you. All right, good.